Okay, so we're in chapter 6, and we already talked about terminology, why we need to use modular programming. We know how to define functions, how to call functions, how to create a prototype and the use of the prototype. We learn how to send data. In the calling, we use the name arguments, and in the header, function header, we use the name parameters to send and to receive. And what we're sending is a copy of the data. That's why we call it passing data by value. We already learned how to return a value by using the return statement. And we know that we can only return one value from the function. And when the value returned, we can use it in a cout. We can use it in a variable. We can use it in a if statement. We can use it in any other statement. And we saw some programs with that to exemplify what we were talking about. Any questions on that? Today we're going to start with section 6.8. 6.8, which is passing then or returning a Boolean value. Returning a Boolean value. Okay. Remember, Boolean value is the state of true or false. So if I'm going to be sending this value, then my return data type has to be Boolean. So in my prototype as well as my function header, I have to start that line with the keyword BOOL. And then, of course, the name of the function. Then we open the parentheses and we enclose in the parentheses the parameters. So when we return inside the function, we're going to use either the keyword true or the keyword false. One of the applications for this type of return is when we're using an if statement in the calling function. That can be main or any other function. And an example is right here. I'm going to go through this. So we're going to make a line right here, and this is going to be main. From here down is main. Let's suppose that we have different instructions right here, and then we have an if. If, remember, we open the parentheses, and inside the parentheses, we have the question, the condition. So in this case, they don't have a question. The result of the question of that test is always a true or a false. Because if the answer to the question is true, if we are the computer, right, the system is going to execute the true part of the if. If the answer to the question is false, then the execution is going to be transferred to the false part of the if. Well, that is the answer for the question. It's always true and false. So the same thing is going to happen here. But instead of having it's x greater than 1 or things like that, what they have is they are calling a function. The name of the function is valid. And they are sending score. Score is a value. Let's suppose that what they send is a 50. Okay? They have a 50 right here in score. And this 50 was placed somewhere here before with a cin, with an assignment operator. We don't know. But we have a 50 in that memory location score. So we're calling on the function is valid. So the system is going to go and look for the function. Oh, here it is. Here's my function is valid right here. I know right away that I'm going to be returning something because I have the Boolean right here. and I'm going to be receiving the 50 that I have in score is going to be copied into BAL. So now BAL has a 50. Why? Because this is the argument and we're sending it, and it's being sent and placed right here, a copy, right? So now I have a 50 in score and I have 50 in BAL. We go inside the body of the function. Here are my curly braces, the beginning, here's the end, and we're going to put int, min is assigned the value of 0. So we put a 0 in min. And then max is assigned the value of 100. So we put 100 in max, 100. Then we have an if. And in this if, we're checking if BAL, which is 50, right, is greater than or equal to min, which is 0. Is this yes or no? Is 50 greater than or equal to 0? Yes. What is this? And. So we have to check the other one. And BAL, which is 50, is it less than or equal to 100? Yes. So both of them are true. So the whole answer for this question, this is a question, right here, is going to be true. What happens if it's true? This part of the if is executed, right? And in this part we have what? Return true. So true is going to go through the pipeline of bool, which is correct, and it's going to be sent back to this place right here. So this now is erased, and we have what here? What was returned? True. So this is what we have here. True. So now the if that is here in main, right here, is going to be executed, whatever we have here. Okay, questions? Okay, we're going to do it again, but now with a different value so that we can test it one more time and we can analyze this. Okay, so again, remember, this part is in main. And we have some instructions here. Let's suppose that here I have a cin, and I'm asking the user to give me score. I have score right here. So the user types a -1. So a -1 goes into score, right? Everybody with me? Okay. So now we have if, the next line that we have here is this one. If function is valid and send score. Again, we're calling this function and we're sending what value we have in score. What value do we have in score? A -1. So we're calling the function is valid and we're sending a copy of this value. So where is valid? It's here. So we're sending the -1 and it has to have a location in memory. So here it is. Remember, this is the argument and this is the parameter. So this -1 is going to be copied into BAL. So we have a -1 in BAL. And we enter the body of the function. And we start, okay, min is going to be set to a 0. So this goes in memory. Max is going to be 100. So this goes in memory. And we have here, is value, BAL, greater than or equal to min? No. -1 is not greater than or equal to a 0. So this is false, right? This one is going to be true. Value is less than or equal to max. That is correct. -1 is less than or equal to 100. So I have here a false and a true because this is and what is the answer to all this? False. So everything is false. So now the system is going to jump to the else part and is going to return what? False. So false is going to go through this pipeline, right? And it's going to come and is going to now replace all this. And now we have here false. So with false as the answer, this is going to take another route, right? Whatever that is, whatever we have here. So we have here the use of the Boolean in the return. We can only return true or false. We cannot return yes or no, 1 or 0. No. We have to return the keyword true, the keyword false. Here is the call. Here is the function. If I'm going to be using a prototype, this is the way that I'm going to write it. Ooh, I'm sorry. Boolean is, this is the name of the function, then open and close parentheses, and then whatever arguments, whatever parameters we're going to be receiving here. Right? In this example, they only have one, but we can have as none or many. Questions? This is just to give you an idea of where we can apply functions. One of the methods that we can use is when we're using menus. Menus is a very good place to use functions. Why? Because if I'm going to be creating a system, let's suppose that they ask me to create the system for TSC registration of our students. So I'm going to have the menu to add. I'm going to be adding classes. The student, if they select 1, is going to add a class. If they selected 2, the student is going to be dropping the class. If the student selects a 3, we're going to be printing the statement of charges. So I have 3 different things that I'm going to need to do in my program. So they assign me this project. The first thing that I'm going to say is, hey, this is going to be a very extensive project, so it's going to take me like 6 months to do it. But they need for me to rush. They need this program to be ready maybe in 2 months so that they can have it up and running when early registration starts. So what I'm going to do, instead of doing all the program by myself, I'm going to separate it into modules. This is going to be one module, and I'm going to be assigning it to one programmer. This is going to be another module that is going to be assigned to another programmer, and this is going to be another module that is going to be assigned to another programmer. So I have 1, 2, 3 programmers plus myself. I have 4. And we can all be working at the same time. So instead of finishing this project in 6 months, I can cut it down to 2 months because we're all going to be working at the same time. And at the end, what we're going to do is we're going to be integrating. If I'm going to be the one in charge of main, I'm the one that is going to be leading all the effort. So I'm going to tell programmer that is going to be doing the addition module, okay, this is the prototype that you're going to be using. I'm going to talk to the second programmer that is going to be doing the drop, and I'm going to again give the prototype of the function. And again to programmer number 3 that is going to be doing the module for printing, and I'm going to be giving them the prototype. And then at the end, I'm going to be receiving all the functions and I'm going to put it together. So this is going to be very efficient, and is going to be we're going to complete the project in less time. So this is one of the places where we can apply the functions. For our next assignment, that's what we're going to be doing. I'm going to be dividing you into groups, and one of you is going to be doing main, and then and the rest of the group is going to be working in the different functions. Okay, we're going to start now with memory allocation. Like I told you, this is what we're going to be discussing today mainly. And before we start, I want to just remind you, what is a local variable? What is a local variable? We have been using this since PF1. Anyone? Good guess? Memory allocation, okay, yes, that's correct. Here they are defining it. It's defined within a function or block. Accessible only within that function or block. Other functions and block can define variables with the same name, but it's going to be totally different. Totally different. Let me give you an example. Let's suppose that we have main. I have main right here, and inside main, okay, this is of course int main, open and close parentheses, and then we have the curly braces, right? So I have a curly brace right here, and then it closes here with a curly brace. Then I have an int add, open and close parentheses. And I'm also going to have a void drop, open and close parentheses. And of course I have the curly brace right here, my curly brace right here, curly brace here, and curly brace here. So how many functions do I have? I have 3, right? One is called main, and probably from main I'm going to be calling an add, and I'm going to be calling on drop. Okay. Then in main, I'm going to be using a variable. That is, so I'm going to be defining int x is assigned the value of 10. In add, I'm also going to be defining int x is going to be assigned the value of 100. In drop, I'm going to have double x is going to be assigned the value of a negative 3456.987, whatever that is. Okay, so we have 3 different functions. Everybody with me? And I have, okay, so what happens here is, let's visualize RAM. This is main memory, RAM. So the first thing that RAM is going to do, and it already knows that it has 2 functions plus main because of the prototypes that we have here on the top. What it's going to do is going to separate an area, and it's going to say, okay, this area is going to be for this program. All this area is going to be for this program. But this program is going to be using main. So here it is. This is all for main right here. And then inside main is going to be using two more functions that is going to be calling the add function and the drop function. So it's going to separate the area for these two functions. So if we are the computer, okay, we go in and we start working with the curly brace. Here's the beginning, here's the end. So we have create a variable called x and put a 10 inside. So this is main. We open the box and we're going to put here x and we're going to put here 10. Then we call add. Let's suppose that here's the call for add. So we call add, and in add we have create x and put 100 in there. Where do you think this is going to be created? Where the add area is, and the add area is right here. So we have another box that is called x here, and we have 100 inside. Then we have call drop. So we have a D here. Call drop. So we move execution to this value, to this function, and we start and we have create an x that is going to have a negative 3456.987. So we create the x right here, and it's going to have a negative 3, 4, 5, 6, 7, and so on. Then my next line here after the call, right here, is going to be cout x. What do we display in main? A 10. That is correct. Why a 10? Because this x is the one that lives inside main. The other ones, they live inside another block. So we don't talk to each other. If here I do the following, x plus equals 50, which memory location is going to be affected? This one right here. This 100 is going to become what? 150. Do we change the x that we have in main? No. Did we change the x that we have in drop? No. Okay. So it's like we have a brick wall right here. This area is separate from this area. We have 3 different variables, and the 3 of them have the same name. That has no conflict. When the function add ends right here with this curly brace, everything that is in this area is released. We don't have it anymore. It's gone. So this x doesn't leave anymore. It has a lifespan within the block. It dies. We're going to drop, and we create x with a negative 3456.987, which is this one right here. When the execution gets to this curly brace, again, this one dies. And then we can continue in main. When main ends, when we close the program, because that's what happens when we get to main and we get to the curly brace, again, we release memory and everything in there dies. We release it. So let's see the information that we have here. Other functions and blocks can define variables with the same name. We already saw that, right? When a function is called, local variables in the calling function are not accessible from within the call function. We already saw that. We have 3 different x's, and each one belongs where they were created. A local variable only exists while its defining function is executing. We already talked about that. When it gets to the end curly brace, everything is wiped out. Local variables are destroyed when the function terminates. That's exactly the same thing. Data cannot be retained in local variables between calls to the function in which they are defined. That means if I call again add, it's like I'm starting all over again because everything was wiped out. Okay. I want to make sure that you understand each of those lines. Okay, that's why I gave you the example first, and now we're reading them, because sometimes when we read them, it's hard to understand until we visualize it. Now, those are local variables. We have another type of variable that is called a global. A global variable is going to be defined outside all functions. So that means it's not going to be defined in main. It's not going to be defined if we're using add and drop, using the same example. It's not going to be defined in those functions. It's going to be defined outside so that it can be used by all the different functions. Okay, all the different functions. The way that we're going to do it is we're going to put it outside main. So that means if I start my program, I'm going to have what? Pound include, right? Whatever I need here. Then I need using, namespace, and so on. Then I can have prototypes here. And then here is where I'm going to be creating my variables. So I'm going to put here intx. It's assigned the value of 10 and then semicolon. And then here I put my main, open and close parenthesis. Somewhere here I have my int add, open and close parenthesis. And then I have somewhere here double drop. Open and close parenthesis. And of course I have the curly braces. Here's main, so I have curly brace here and it ends right here. This is add, I have curly brace here and it ends right here. This is drop, curly brace here and it ends right here. If in main I have cout, cout x, okay, let's see what are we going to have here. This is our program now. So we are the computer. We start with the first line, include, using names. We have the prototypes, and then I have here, this is a local variable or a global variable? Global. Global. Why? Because we defined it outside, and this is what we're doing, right? A variable defined outside all functions. I did not define x inside main. I'm using it, But the definition is where we start and we introduce it, like int, double, character. Okay. Here, I'm not defining it, I am using it. Here, I'm not defining it, I am using it. So this is a global variable, x. So what happens here now is going to be the same. We have RAM, so we create RAM, we're the computer, remember, and then we say, okay, we have a program that is going to need main, some area for main, and then 2 smaller areas for the functions, right here. But x is not defined here, it's not defined here, it's not defined here, it's defined somewhere outside those areas. So we have here the 10. So we start with main right here, and we have, okay, the first thing is cout. Cout x, what are we going to display? What is the value of x? 10. That's what we're going to be displaying. Okay, let's suppose that now I call add. This is a call. So I call add this transfer control to this function. We start curly brace, and then we have cout x plus plus. What are we displaying? 11. So we're using the same right here. But where do we leave the 11? Is this going to affect the x? No. Then we go and we have here another one. Call drop. So we're calling drop. This is going to be calling this function. And it's going to say, okay, add 5 to x and leave it there. So now we have what? 15 in x. And we're going to display x. And x is going to be displaying 15. Now we have one single x. Remember, in the previous example, how many x's did we have in this one? Where is it? Right here. How many x's did we have? 3. 3 different ones, and they were completely different memory locations. How many do we have here? Just one. Why? Because we created it outside all the functions. So this is called a global variable. It's an easy way to share large amounts of data between functions. So this is one, but it's not recommended, very much recommended for you to use. One of the problems is that it's going to get complex to debug the programs. Okay, this is the information there. Just like we have variables, we can also use constants. It's the same concept. Okay, a global constant is the same concept as the global variable. We define it outside all functions. The only thing that is going to be different is that we're going to add the keyword const for constant. Okay. So we're going to put constant, then the name of the variable, or the name of the constant, and then, of course, the data type, the name, and then the value. This one you can use as much as you need. It is safer to use than global variables, since the value of the constant cannot be modified during program execution. So they recommend that you use it. And we have one more type, which is static. Static local variables. Static local variables are defined with the word static. They are local in that they are going to live between the curly braces, that block, but they are pretty neat because they can retain the value. They can keep the value, the original value that we place in there, they can keep it, and if we modify that value, they will remember that. So it's like a variable, a local variable with memory. If we initialize it again, if we go back to the function one more time, it will remember, hey, no, the last value that I had was a 5, so I don't go back to 0. It will remember right away. I'm going to show you a small program that we have here in your textbook so that we can exemplify that. So I'm going to ask you to open your textbook, or you can follow me. Okay, we have a checkpoint. What is the difference between the static local variable and the global variable? Remember, global variable is going to be defined outside of functions. And it can be accessed by all the functions. But it has disadvantages. One of the disadvantages is that it's going to be very difficult to debug our programs. The static local variable, it lives within the curly braces, so it's easy to debug our programs. And it has the facility that it will retain its value. Once it exits the function, when we come back, it's going to retain its value. So let's see these two examples right here. They're asking us, what is the output of the following program? So if we are the computer, we start with #include IOStream using namespace std, and here's a function prototype. So I know that I'm going to be working with a function called myfunc, no return value, no parameters. So I start, my first line is going to be in main. So I start by setting a value in VAR for 100. So we put 100 into this variable. Next line, we display VAR. What value are we displaying? 100. Then I have a call. We're calling my function. My function, so we transfer control to this function, void my function, no parameters. And then I have here int VAR, and we set it to 50. Next line, display VAR. What value are we displaying? 50. That is correct, because this VAR, even though it has the same name, it is using a different memory location. So we hit the end and we go back to the call. We check this is it. I don't need to do anything else. So I go to the next line and then I see out VAR. What value are we displaying? 100. 100. VAR from here display 50, but VAR right here displays 100 because it's living where? In main, right? Okay, let's see now with the static. How will that work? We have include using namespace, and we have a prototype void show VAR, and we start main, and we have here a loop. We have a loop. We start for int count is equal to 0. Go inside the loop if count is less than 10 and increment. Okay, so we check it 0 less than 10, it is, right? So we go inside the loop. Inside the loop, we're calling a function that is called show var. So let's see. We go to this show bar and we have static. Okay, so it's a local, but it's a static. Remember, it retains its value. So we have int var is 10, and we display 10. We add 1 to var and we leave it there. So now we have 10 plus 1 is 11. We get to the end of this, go back, and this is the loop, right? So we're going to go back and increment count by 1. Is 1 less than 10? It is. So we go back to show bar. So I go back, and then I'm going to see this line static, but I know that I already came here. So I skip the line altogether, and I do cout. What value are we going to be displaying here? 11, because it retains its value. When it's static, it retains its value. So now we add 1. We have a 12 now. We go back. We increment the value of count. Now we have a 2. Is 2 less than 10? It is. So we go back to the inside of the loop and we transfer control to show bar one more time. This is the third time that we call it. So we come here, we see static, and we know that we already were here once long ago, but we were here. So I skip this line and I go to the next one. And we display. What do we display? 12. 12. And then we add 1 to bar. So now I have a 13, and we go back. We increment the value of count by 1. Now it's going to be, what, 3? Is 3 less than 10? It is. So we call show bar one more time. We come in, again we see static, and we remember that we were here before. So I skip the line, and now I cout var. What do we display? 13. Do you see how skipping its previous value? Okay. And that didn't happen right here in this previous example. Why? Because we use the keyword static right here. var is not a global variable. Okay. It lives only inside this function, but it's going to be able to keep its value. Once we get to the end of this curly braces, we don't lose the values. We keep it. We can create as many static variables as needed. Questions?